Hi friends, this is Rishikesh, your favorite channel Rishikesh Mamadala. Today I am going to explain the proofs of trigonometric identities. Let's start our video. Proofs of trigonometric identities. There are three main trigonometric identities. The three main identities are first one. First one is sine square theta plus cos square theta is equals to 1. This is the first and main identity. And second one, sec square theta minus tan square theta is equals to 1. This is second identity. And third one is cosec square theta minus cot square theta is equals to 1. This is third identity. Now we are going to obtain how they are these identities, how they are obtained, and we are seeing the proofs of these identities. These are main identities in the SSC examination. We are now uh, taking the proofs of first one. Proof of sine square theta plus cos square theta is equals to 1. See, I draw about triangle. I named this triangle as triangle RPQ. This is the hypotenuse, this is the adjacent, this is the opposite according to theta, angle theta. And this is the right angle triangle at angle P. The Kirtan has explained the previous class about the sin theta and cos theta and their formulas. Uh, and this is a now sin theta formula. Sin theta formula is opposite by hypotenuse in triangles. What is a hypotenuse in that? RQ by PR. And now the cos theta. Cos theta is equals to adjacent by hypotenuse, means PQ by PR. And now we are going to prove this formula. We take LHS. What is LHS in this formula? LHS is sin square theta plus cos square theta. This is the LHS in this identity. Now sin square theta means, here I wrote r cube. I wrote sin theta is equals to r cube by PR. Sin theta means r cube by PR. Here sin square there means r cube by PR whole square. Again cos square theta, PQ by PR whole square. Like this, we derive this r cube by PR whole square plus PQ by PR whole square, and is equals to RQ square by PR square. RQ square by PR square plus PQ square by PR square, and this is equals to RQ square plus PQ square by PR square. Since you know this Pythagoras theorem, hypotenuse square is equal to opposite plus adjacent whole square, then we can do this. RQ means the hypotenuse, PR means the hypotenuse. You change this is P, this Q, you change this. I wrote here mistakenly, that's why you can change this P and this Q, You can see that the PR is the hypotenuse, then we wrote PR square here, means according to Pythagoras theorem, and according this below above step, then we can know that RQ square plus PQ square is equal to PR square. RQ is a opposite, and PQ is a or PQ is a adjacent. According to Pythagoras theorem, we know that hypotenuse square is called to opposite plus adjacent square. Like this, we can do that. PR square by PR square means this both will be cancelled and this equals to 1. Here you can write, since that RQ square plus PQ square is equals to PR square. According to Pythagoras theorem, we can do this, and according to trigonometric identities also we can do this. And RHS is LHS is equals to RHS. This identity is proved now. Then we are going to second identity. What is second identity? Sec square theta minus tan square theta is equals to 1. Now we are proving this identity by directly by this in a triangle PQR, by this above triangle, by this triangle PQR, according to Pythagoras, means according to Pythagoras theorem. According to Pythagoras theorem, PQ square is equals to PR square minus RQ square. Then sec theta is equals to hypotenuse by adjacent. Means what is hypotenuse? PR. What is adjacent? PQ. And tan theta is equals to opposite by adjacent. Means what is opposite? RQ by what is adjacent? PQ. Then in this also we take LHS. LHS is equals to sec square theta minus tan square theta is equals to PR square. PR by PQ whole square minus RQ by PQ whole square, then is equals to PR square minus RQ square by PQ square. I took here PQ square common, then we get RQ square by PQ square by PQ square. Then this both will be cancelled and the answer will be 1. And this is also proved LHS is equals to RHS. Now we are going to the third identity. The third identity is cosec square. The third identity is cosec square theta minus cot square theta is equals to 1. Then we are going to third identity to prove this. The third identity is cosec square theta minus cot square theta is equals to 1. You remember this diagram? No, I'm drawing this diagram here again. I'm drawing the diagram roughly. This is the P, Q R. Hypotenuse, this is the angle theta, and it's a right angle adjacent opposite. I am proving this also by the like a second trigonometric identity, means in triangle PQR according to Pythagoras theorem. According to Pythagoras theorem, RQ square is equals to PR square minus PQ square cosec theta. Cosec theta formula, I think, do you know? Cosec theta formula is hypotenuse by opposite. Means what is hypotenuse? PR. What is opposite? PQ. And the cot theta formula is adjacent by opposite. Adjacent PQ and the opposite is RQ. Then we do like the second identity. LHS is equals to LHS means left hand side and RHS means right hand side. By the left hand side, cosec square theta minus cot square theta is equals to PR by whole square, PR by RQ whole square minus PQ by RQ whole square is equals to PR square minus PQ square by RQ square is equals to RQ square PQ square by PR square by sorry RQ square by RQ square. Since both will be cancelled and the answer will be 1. And this is also proved LHS is equals to RHS. Mean the left hand side is equals to right hand side. I hope you understand these trigonometric identities, these proofs. Thank you for listening. Please subscribe and share and like my videos and channels. Thank you.